All right, number 5 is another maximization problem. And we're looking at 3 variables, x, y, and z, and they're real numbers between 0 and 1. And then they got this crazy looking function with absolute value symbols in it. Go to the whiteboard, see if I can figure this out. And I'm trying to maximize this problem number 5. And I know there's an x, a y, and a z in the problem. And these things are contained in the interval between 0 and 1. And we have this function of 3 unknowns. It's going to be the absolute value of x minus y plus the absolute value of y minus z plus the root of the absolute value of z minus x. It would be nice to get into one unknown. And the numbers are between 0 and 1. They're inclusive, by the way. So I'm going to take some extremes over here. That I'm going to say y equals 1 and z equals 0. I'm taking the endpoint. And you can get a function of one unknown over here. Well, you can get the root of the absolute value x minus 1. We'll take care of that later. Plus y minus z. And y minus z would be 1, and the absolute value of 1 is 1, and the root of 1 is 1. That's not so bad. Plus z, which is 0, and that's good. The absolute value of minus x. And since between 0 and 1, it's going to be the root of x. You sure I did that right? Yeah, I think so. I'm looking at this x minus 1, though, and I realize that x is a number between 0 and 1. And so I'm going to rewrite this without the absolute value symbol in it. And a way to do that is if between 0 and 1, the absolute value of that would be best rewritten as, let's think, I always have to think about that. I'm going to say 1 minus x, all right? I couldn't say x minus 1, by the way, because, that could turn out to be a negative value. You want that to happen, absolute value. And say plus root x plus 1. Let's take a derivative, see what happens. F prime. Well, that's one step at a time. So 2 root 1 minus x minus 1 plus 2 root x 1, using a chain rule, by the way. Derivative of 1 is 0. My analysis is going to take place between 0 and 1 for the x. Let me rewrite this as, I'm going to solve for 0, by the way. By the way, x can't be 0. Get rid of that guy. And it can't be 1. I'll exclude that now. So let's write this over here as 1, 2 root 1 minus x. I'm getting the 0 now, by the way. And the 0's got to be between those two numbers there. What do you get there? You get root x equals a root 1 minus x. I'm going to square both sides. You get x equals 1 minus x. 2x equals 1. X equals 1/2. All right, let me just see if I've read the question, understood what the question is. Let x, y, and z be real numbers. What's the maximum possible value of this thing? And I think I got it. All right, so let me go back and review what we got. We have x is a half. I got y is 1. And I got z is 0. And let's go back to the original function and find out what the maximum value of it is now. So we have this over here. And we're going to plug it in a moment. Let's see, x minus y. That's 1/2 minus 1, which is minus 1/2. The absolute value of minus 1/2 is just 1/2. It's y minus z. That's going to be 1. And that's going to be z minus x. And again, it's going to be root of 1/2 now. That's going to be 2, this over here, plus 1. I'd like to rationalize this if I can. This is going to be 2/4. You get 2 root 2 over 2 plus 1. And you're going to get root 2 plus 1. And that's the end. Thank you.